Alright, friends and neighbors, welcome back to another wireless networking video. Today we're going to talk a little bit more about some of our basic components or building blocks, and then we're going to go through our first operation. So without further ado, let's dive into access points and joining a cell. So I think as part of our last video we were talking about building blocks, and the building block that I would like to focus on right now is our basic service set. And we are going to talk about what that access point does and how nodes communicate with the access point when they want to join a cell. Now, of course, we have the bigger topologies. We have extended service sets. We have to add the distribution system and stuff like that. But today we're just going to really focus on that access point. And of course, the nodes in this case can be any kind of node out there. So what is the job of the access point? Well, number one on the list, I suppose, is coordinating traffic within the cell. Now, if you think about that for a sec, the access point can have lots of nodes connected to it, but the access point also is the connection point between the wired and the wireless sides. So when we connect to the distribution system, we're actually creating that extended service set that I mentioned earlier, but of course we've got all of the stuff that's going on in the cell. Now, the weird thing about wireless is that while we all want wireless, it's nowhere near as good in terms of efficiency as a wired network. And for that, I say that for a lot of reasons. Overhead, the shared media again, and as we go through this series, you'll come to understand why I say that. But of course, wireless is so doggone convenient. We don't have to be tethered, we don't need power outlets, we don't need any of that stuff. So for a lot of reasons also we want wireless, and they're all good reasons. But the access point has to govern all the communication within the cell between the wireless nodes, which is a shared media. Now, if you go back to the Ethernet stuff, we talked about the access method, the way that nodes take turns sending data. Well, we have an access method in the wireless side too, and it's called carrier sense multiple access with collision avoidance, and so the access point has to manage all of that. So the access point talks to all the nodes, it governs the communication with the nodes, it issues the beacon frame every 10 to 100 milliseconds, and when you think about that, even on the slow side, that's 10 times a second this beacon frame goes out. And of course, it has to advertise all of the communication parameters for the cell. After all, it's in charge. And if you want to join me, says the access point, here's how we're going to work things. It's got to keep track of all the power saving nodes. So there's a whole bunch of stuff that the access point has to do. And as we get more and more into operations, we'll talk about each of those in their own turn. Our first wireless frame. Well, I'm going to show you some wireless frames today, so I thought I would point out some of the highlights. And when we're dealing with a wireless frame, it has a lot of similarities between, all of the frames or all of the packets that we've looked at before, but there are some significant differences. Top of the list is the type and subtype. So there are a couple of different general categories of wireless frame. We're going to be dealing with management frames exclusively today, and then we've got the subtype, and for us today that's going to be beacons and probe requests, probe responses, authentication, association, all of that. There's a series of control flags in the wireless header, and these tell us what's going on in a particular network. So in this particular case, we can see that maybe we've got some power management stuff going on. Is this going to or from the distribution system, things of that sort. Now, another very significant detail in a wireless frame, and one of the things that distinguishes it from a wired frame, is that it has 3 addresses. Now, technically it could have 4, but most just have 3. And those are the source and destination, makes sense. Now we're talking about MAC addresses here, but the other one is the BSSID, not to be confused with the SSID. The BSSID, or the basic service set identifier here, is the MAC address of the access point to which this goes. Now this also is the access point that's sending this particular one. And then just for fun, I've highlighted the beacon interval down here. This one happens to be 100 milliseconds. Okay, so let's talk a little bit more about that access point. the access point is the originator of the server set identifier. You can put it in your node, but your node is not the thing that controls it. The access point controls that. So in an access point configuration, you tell it what you want its SSID to be, and then nodes will join that SSID and eventually become associated with the access point. Now this is an alphanumeric string, and there's lots of reasons why you move off of the default SSID, right? Just basic good security sense. And we a lot of times create SSIDs that have some meaningful designation. Nodes have to know the SSID of the access point or of a network. Now, a lot of access points can have the same SSID, and the minute you do that, you have an extended server set. So individual access points can have an SSID, and they can be part of a collection of access points that all have the same SSID. By the way, if you do that, they're also going to have the same security. It should be on different channels, but they'll have the same security. Now the SSID, or knowledge of the SSID, is sort of our first line of defense, but it's not really a security measure at all. Even if you hide the SSID, you'll see here in a sec that nodes broadcast it themselves. Now I've got a node up here in the upper right. Where would that be? Right above me here. And that is a wireless home gateway. And I just want to make the distinction between an access point and a wireless home gateway. They are not the same thing. A wireless home gateway includes the functions of an access point, but it does a lot more than that. An access point has a very particular job, so they are not the same thing. Now the other thing that an access point does is it synchronizes all of that traffic. Now I mentioned that it's the connection point it's the connection point between the wired and the wireless, and it has all of those wireless nodes to manage. So all of those wireless nodes have to be very, very conscious of the time setting for a particular cell. And so that's how we synchronize all of the traffic, and that's what the access point provides. So let's talk about our first operation, and that is joining a cell. Before you can do anything on a wireless network, you've got to join a cell. And there are 3 stages to this. We have to probe, we have to authenticate, and we have to associate. To do this, we need the clocks to be in sync, and we get this information from the access point. Okay, so the minute a node wants to join, or the minute a node wakes up, or the minute a node roams, we need information from the access point that we're going to roam to, that we're going to connect to. And so normally we would get this, well, I won't even say normally. You get this really one of 2 ways. One is if you're just sitting there and you're passive, you can pick it up from a beacon frame. So a beacon frame will give you all the communication parameters for a cell. If you're a little, in more of a hurry, then you can do what's called probing. You can do a probe request. Now there is a fundamental difference between beacons and probing as far in terms of operation, but they essentially provide the same information. If you probe, you're asking for an answer from the access point. Then you have to authenticate and you have to associate. We'll talk about those in their turn. So here is a more complete look at a beacon frame. Now I've collapsed part of the header so that we can see some more of the details in the beacon frame itself. The beacon is actually quite a large frame because there's a lot of information in it. But at the top we can see the type and subtype that are the beacon. And we can also see the beacon interval right here, 100 milliseconds. The flags in the middle here, there's a whole bunch of them, and I've actually collapsed a bunch of these. Modern wireless networks have a lot of single-bit indicators that tell us what's going on in a frame. And we can see in this particular one that it is an ESS type network, meaning that there's more than one access point out there, and it's connected to the distribution system or the wired network. In addition, this one has privacy going on. Now we can also see in the beacon that we have the SSID being advertised here, the Rouge Jules Verne. We've got data rates, we've got the traffic indication map, all of the timestamps, we've got a channel that this access point is sitting on, and then we've got all of the data rates that this access point will support. And then lastly, we've got the security stuff. So a beacon frame, if we expanded all these, would actually be enormous. Now let's say that you're not passive, you're not looking for a beacon frame, you want to find the access point right away. Well, in this case, we're going to do something called a probe request. And the probe request is the node saying, hey, listen, I want to find out the information for the cell right now. I want to join right now. And so you can sort of imagine that if the beacon frame comes out 10 times a second, that this is a really aggressive approach, but a lot of nodes use it. We can see the type and subtype. Again, we're a management frame. We've got a probe request here, and this one is going to a particular MAC address for the access point. So this is the access point that we actually want to use. Now, sometimes you don't know the MAC address of the access point. So if you already joined an access point, you might be able to send this to an access point. But if the access point is unknown to you, then what you're actually going to do is you're really probing for an SSID. And you can see that we've got the SSID again here in the probe request. Now that's the funny thing about it. A lot of people say, well, if you're going to be secure, you want to hide your SSID. You don't want to broadcast your SSID. But if somebody's listening with software like I've got here, this is just, we have EtherPeak or OmniPeak, well, your nodes are going to advertise the SSID because they're going to be looking for it. So that's not really a security thing. And so the node is also saying, hey, these are the things that I can do. Well, in response to a probe request, we get a probe response. Makes sense. And if you take a look at this probe response, other than being a different subtype, it has all of the same information that the beacon did. And so this is just another way to join the cell. So a beacon and a probe response have almost the exact same information in them. And that sort of makes sense because at this point we are really trying to join the cell. The next step in joining a cell is authentication. So the original two flavors of authentication, these are part of the original 802.11 standard from the IEEE, are just open and shared key. So if it was open, well, it's really this. Can I come in? Sure, come on in. If it's shared key, you just have to prove knowledge of a shared key, and the way that you do that is you encrypt a challenge, and then that comes back. So this has largely been replaced by WPA, WPA2, but that was part of the original standard. So if it's an open network, then what we have is two frames, and it's not really authentication then. It is just, like I said, can I come in? Sure. If it's shared key, you are going to request, then a challenge will be sent to you, and then you will encrypt the challenge, send it back, and if the access point decrypts it the same way and gets the resulting or the original challenge text back, then you passed and you're allowed in. By the way, the reason I have the challenge being bad here is that what you're sending across the network is an encrypted and an unencrypted version of the same text. And so bad guys, bad actors can take a look at those two and just brute force what the key might have been. So here is an authentication request. Again, management frame, authentication type or subtype. And then in this particular case, we have an open system. So there was no challenge in this case, but there you have it. These are also very small frames. It is just really the header and then details about the authentication type. We follow this up with a successful authentication response. But other than that, this is from the access point saying, yeah, you're allowed in. The last stage in joining a cell is the association. So you've passed authentication. It's now really time to join the cell. And so the access point and the stations are going to swap information about the capabilities, and they're going to agree on how they're going to communicate. But the key idea here is that now the access point realizes that this particular node joined it, not the network, but joined this particular access point with this particular SSID. And the access point now puts this node in its association table. And now this access point knows that it and no other access point will be charged with the responsibility of forwarding this node's traffic. No other AP will do it. So this goes in, or the MAC address of the station goes in the AP's forwarding database. And then after that, regular data communication can occur, and we start using a different kind of frame called the data frame. So here is an association request, right? It's just the same thing, management type, and an association request subtype. Again, this goes back to a particular MAC address of an access point that you are associating with. We've got the SSID details and all of the communication parameters that we're now going to activate. The association response, management type, subtype is the 0001 that you see there. And this is just the access point saying, yep, I am now going to add you to my forwarding database. You are now with me. Well, all right, huzzah! This has been a little closer look at access points and some of our components and our very first operation, which was joining a cell. We talked a little bit more about what the access point does, and we find out that it actually has a lot of responsibilities, a lot of jobs. The connection point between the wired and the wireless sides, then all of the communication parameters, the beacon frame, and then managing all of the traffic within the cell. We also talked about the 3 stages of joining a cell. You're going to scan, and you'll either do that passively with the beacon or actively with a probe request, probe response sort of exchange, and then the authentication, and then the association. Hey, thanks for watching. Thanks for listening. Like, subscribe, and hit the bell icon if I helped. And may those wireless packets always reach their destinations. But you got to join the cell first.